Hello and welcome to this edition of AI Insight. And today I have a very good friend and a really a thought leader and a practitioner in the space of modern data platforms or all data platforms, probably for last 15 years or so. He's probably seen it all and done it all. So this is Mazhar Chaudhri or Maz Chaudhri. Mazhar, welcome.
Thank you. Thank you, Amaresh. Thanks for having me.
Yeah, and
Looking forward
Mazhar,
to it.
just for the folks who are listening, he's been a leader in running data platform and analytics teams. He's worked in companies like United Healthcare, and Medtronic. He's been a consultant, Deloitte, PwC, Slalom. So he's kind of seen both sides, has advised a lot of companies about it, has done it and led teams doing it. He's done it in healthcare, financial services, couple of industries. So he's kind of been there, done that pretty much if it comes to data platforms. So Mazhar, we are thrilled to have you and kind of share some of your insights.
Absolutely. Looking forward to this, Amaresh.
Wonderful. So Mazhar, let's set the context a little bit. Help set the context because you probably have seen the entire evolution of data platforms, right? I mean it was like on-prem and kind of from the world of Teradata to kind of Hadoop to kind of the cloud data platforms and Snowflake, this thing, and whatever is kind of coming next. Can you just walk through the journey of the data platforms in the last 15 years in enterprises? What has evolved? And more importantly, if you can just go and focus on what problems have you really solved already with the current state of the modern data, like the cloud-based data platforms today, and what problems still remain to be solved?
Yeah, I know it's a great question, but also tough questions because no, we industry and especially the technologists have what I would call the shorter attention span because technology continue to evolve and their interest or passion about the technology continue to evolve with that. So let me just talk about, especially in the context of, okay, now the all talk about AI, right? But I'm going to go back and say, okay, it started with my journey, at least started with relational databases, right? When the
Mhm.
warehouses were built on relational databases.
Right.
And the discussion was that, okay, relational databases are not designed for large analytics querying, especially with the large volume of data when you are processing it through the memories in the real time. So that's where the appliances came in, distributed computing came in, and that's where you hear all the Teradata and the Exadatas
Right.
and the Hewlett Packard platform. Now I'm blanking out on that.
Vertica.
Vertica, right? So and almost every client that you might have worked with and I've been at have either the one of those, right? Either
Yeah.
Teradata or those.
The
So I
team.
think that from solving the problem, all of them solving problem. I've been at one of the client you just mentioned without mentioning a name. They have a DB2 based data warehouse. And I think that was the most successful implementation and still in production and working well, right? So is
Correct.
it solving their business problems or needs? Yes, it was. But it was the industry always been chasing, okay, what's the art of possible? What could we do more and different with the technology, right? So business problem, business requirements are already met, but how can we do more? That's where the appliances came in. And while we were still implementing appliances and lost more customers, then Hadoop came in and they say Hadoop it's a paradigm shift, right? And you and I work on Hadoop based ecosystem or data architecture. That became legacy pretty fast. But one of the things I wanted to point out on Hadoop that while in the appliance architecture with the distributed architecture, it was okay bringing data to the compute.
Yeah.
Hadoop promise was, okay, we're going to bring compute to the data.
Mm.
So the storage was not expensive. You got to have almost infinite storage. You can bring all the data and we'll bring the compute as needed. Now, as we evolve into this AI world, and I always question myself, especially in an enterprise architecture, okay, well, Hadoop promise was, the traditional was bringing data to the compute. That's why we have distributed computing. You have nodes, you're processing data and convert. Hadoop was, okay, store the data in its nodes and and bring a compute to the. Now, when we talk about large language models now, okay, or any model for that perspective, what is it? Are we bringing those data to the models, or are we bringing model to the data? And that's the questions that in my head, right?
Right.
And I'm thinking, okay, what is the implication of that? in an architecture that's now fast forward from even Hadoop, and now it's in the cloud, right? So bigger organization, as they made investment in these large data appliances, right? They also made investment in cloud data warehousing. Bigger three, at least there, right? The big three competing, Snowflake is, and Databricks, and you have Microsoft Fabric, and now OneLake, right? So the question is that if you have already made an investment, and that's the question we're trying to answer, if you have made an investment in one of these, and now you have AI generative, what's the implications on, and what's the consideration as you have, what in consideration of your data strategy and data architecture? Going back to your questions, what we have solved and what we have not, I think the problems and the use case continue to get solved, but the new use case continue to emerge, and the technology itself actually creating new opportunities, right? Yeah.
But what are, like, think about, let's talk about like Snowflake, and I mean, basically I think we are in the age of cloud data platforms right now. I mean, there's a fair bit of like modernization still happening, but fundamentally, if I were to ask, what does cloud data platform solve that earlier could not be solved, or what use cases it enables that earlier it was not enabled? Like, what's the easiest way to think about that?
You know, I'm a little bit optimistic, a little bit pessimistic at the same times about this. I think that, and that's where you and I have last time the conversation about this is too, that related to economics of it, right? So the whole idea was that cloud would solve the similar problem that on-premise infrastructure solved.
Okay.
But the promise of cloud was, and still is, but that needs to be that yet to be really realized, is that promise of cloud was that it will solve in a more economic way, in more efficient way. That's number one. And the second is it will enable the speed to market, mean you have almost infinite scalability in the cloud. So you don't have to go through the process of procurement and get your infrastructure, enhance your infrastructure, or augment your infrastructure. So that the time frame that you have, that definitely is cut down, and speed to market is increased. So think about the speed to market and economics of it was the promise of it, and scalability perspective. You can scale it. You can scale the Teradata appliance sitting in your data center. You can scale the Exadata appliance sitting, but you got to add more capacity to it. So that adds more time and the process. In the cloud, the idea was that you can scale it infinitely. That's one thing.
Okay.
But the second was economics, and that's why I want to talk to you a little bit about that, because
before we get to economics, but the other aspect, this is just kind of at least how I think about it also. It doesn't the cloud data the cloud data platforms fundamentally shrink the analytics cycle, because like, if the other part of it is you're talking about compute and data, kind of where it goes there, it's kind of where you build the models and where you deploy the models and where you do the analysis and how you deploy it. That cycle has also shrunk because of kind of the tooling here, or is it like just not probably because of, is it, I don't know whether it's because of just the cloud, but the tooling right now is a lot more integrated than it was like 10 years ago.
Yeah, great point. I think that gave me ideas to actually answer your first questions, what we've solved for. I think one of the promises of cloud was, okay, well, you can accelerate the delivery, but why you can accelerate? One top, we talk about infrastructure scalability, but also was you have these ecosystems of component solutions available from the cloud marketplace, right? So you don't have to build everything yourself, to your point, right? Yeah. You have a tool, you have a component that you can use to accelerate and actually shrink that cycle, right, for that purpose. However, what I'm seeing is, and what I look at it, when organizations make decisions, there are two aspects of it. There are multiple criterias, right? But one of the things that I've been passionate about is that it always comes down to, if you start looking at these platforms and you say, okay, do they have this capability, the storage and compute, and okay, can you do on-demand store? Can you shut down? Can you do that, manage? Yes, they all do it. But one of the criteria that at least I have used in our decision making is that what kind of talent pool or skill set you need to not only build but operate that infrastructure or that platform. And I think that what I would in my humble opinion would be that, let's use for two examples, like Databricks, for example. Yes. Databricks solve kind of similar problems that Snowflake is, although Snowflake came from the warehouse side of it, if you look at this, and the Databricks came from the Hadoop side of it, like, Spark and etc. But they both have been converging, right? And especially in the marketplace. But their strengths are all a little bit different from where they grew up. So on the Databricks side of it, it's always been you need really a full stack development experience, right? On the Snowflake side, people who grew up and kind of hail from the warehouse and SQL side of it could be very well can transition into that. So you don't need a full stack. You really need traditional data warehouse skill sets. But what to your point, yes, you can shorten the cycles. But what I'm seeing is by using that's all this modern data. Remember, modern data architecture component was that you don't build a monolithic data warehouse like Teradata. You gotta look at the best of breed as the components put together. When you're really building a modern data architecture, really building, I think that first and foremost is really the skill sets that you really need, and almost a full stack skill set you need to really build and operate modern data architecture. And that's so true now, the world that we are operating right now in an AI world.
Right. Absolutely. So now transitioning a little bit to the world of AI, right? I mean, I know which is like you had a lot of experience in some ways not only building like modern data platforms, but I know you were building an AI platform, right, in the organization. Uh, is it like will enterprises have two platforms? Will it because of what Snowflake and Databricks are doing, they will all converge into one platform? Like how do you see like this whole data platform and these AI platforms and the capabilities that will be there? How do you see the picture like 12, 18 months from now or 24 months from now in enterprise data? You know, how does this AI thing come into play?
Yeah. So Amaresh, if I could replay back to understand, you're thinking about you're talking about it used to be, or at least we say data and analytics. Now you're hearing more data and AI, right?
Yes, that's
So
right.
what does that look like? The world look like from data, again, data architecture and data platform perspective. I think I'm learning as the industry is learning, to be very honest and transparent. But I see that data architectures would have there will be a consideration and decision point for organizations. Now I've been reading about a little bit more, and I'll talk about there is a solution, but also there is economic problem with that. So what for example, some other organization made a significant investment in moving to the, let's say, a hyperscale AWS cloud, the data warehouse on AWS, Snowflake, take an example. But when this the Chat GPT became a household name, and everybody consumer got excited first, and then enterprise like, holy cow, we FOMO, we have fear of left behind, right, missing out. So now the first entry, I think the Microsoft partnership with OpenAI, Amaresh, they have a first mover advantage. And enterprise always go with the bigger and better or whatever you think of it. So they think more of, okay, should we think of AWS? Should we go to the GCP or should we go Microsoft? And the first use case is always continue to be a document and AI. So that's natural for organization to move. Okay, well, the Microsoft, right? So what I'm seeing, at least the organization where I'm leading this large organization, or in my consulting world, what I've seen it now, and you can add to that, or maybe you have more consulting experience, that in that case, you have a cloud data warehouse investment in the public cloud, and you building your generative AI platform, another hyperscaler, yes, let's say in Microsoft in this case. So what is your data architecture strategy in a bigger schema, right? Are you going to have these two platforms sitting on two hyperscaler? And what about the egress and data movement and etc.? Or would gravity will work? It will go one way or another. I think that's the question I have been scratching my head. And I was having a conversation with one of your team members, is that agent architecture might solve it, right? Yeah. However, when I'm reading more and more, I'm not a coder, I'm not a deep in that, but what I'm reading about that agent architecture would solve it. But again, one of the things I'm really passionate about these days, Amaresh, I keep coming back to it because that's the problem I was trying to solve in even the data warehouse side of it, is the economics of it, right? So agent enabled workflow or multi-agent architecture could solve that problem. Okay, you could run some here, you can run agent there, you can have this orchestration of these agents and the crew and etc. But you're calling these LLMs very frequently, right? Yeah. Okay, now that's also going to add the cost of it, right? So what's the implication on the cost? And what's the return on your investment from value perspective?
Got it. Right? So, and we'll get there. One question, but when you see the Microsoft ecosystem with OpenAI, and then you see kind of pretty much everyone else, right? Then you see what Snowflake and Databricks are doing. do you think that those worlds will converge, or do you see like Microsoft using their position to kind of get more of enterprise data kind of platforms into their mix? Like, where's your bet?
Well, then as a data and analytics leader of the organized data platform and services leader, I saw that. I see that, right? Now, where things will play out, while Snowflake and Databricks going head and head, right, to fighting about their own territory, I think Microsoft has a long-term strategy to really pull, if you think of this, pull the word, lack of a better
Yeah.
word, this generative AI platform and large enterprise towards it. And I would just go on a limb and say the gravity might serve, and it might be favorable for Microsoft in the long run. So I see that until this what I'm talking about. I'm learning the agent architecture,
Yeah.
and Rach, as you are learning, is that something would work against that gravity? I don't know,
I
right?
don't
That's
know.
yet to see.
Yeah. So now let's talk about economics. I know you're passionate about that, right? Because obviously, when you are outside in, I mean, you think about the economics of this thing, but at scale, when you're running it within an enterprise, that's obviously a very big factor, right? I mean, kind of how to think about the economics of both the data, because these pricing models are very interesting and very creative in different ways, and now you add the LLM costs and everything. What is the framework? I mean, if you could just at least help think about, if you run a data platform, right, or if you run a data and AI platform in the future, what is the fundamental framework around which you think about, okay, here is how I think about the economic model of that, and then what levers do I have to play with to manage that? So how do you and is there a good framework to start with?
Yeah, I this is I don't know if there is a framework, but I can tell you my own experience and knowledge about
Yeah.
that. But let me highlight a couple of problems before we get to that framework, right? So one of the problem is, and that's the age-old problem now. Age-old mean maybe age in our world that we operate in. Age is 5 years old, right? 5, 10 years old is an age old. So I think that's why I keep going back to the promise of the cloud. And you say, what problem it have solved? Promise of the cloud was it will do with scalability and speed to market and more efficiently and cost. What we haven't thought about it, and while we were moving really fast, the on-premise to the cloud, is that the shift will happen from the capital to OpEx, right?
Yeah.
Okay, some new organization that really focusing on building a new capability or software as a service products, and that might be okay because they're starting with the new scratch. They don't have capital investments. Their process and budgeting process are not capital intensive based, so their OpEx they could find. But the large enterprise, usually we talk about the Fortune 5,000 or Fortune 500, whatever those are, and especially when in my experience is that you got to think about not only the shift from capex to opex, right, but also shift from what kind of enterprise this. I've seen that, what I've experienced, that manufacturing organizations, right, that make product, they make a lot of their investments is capital investment.
Of course.
They're very oriented towards financing capitals, right, because they do in manufacturing, they're very good at it, right? And the same mindset is we're going to capital is easier to procure, and buying a capital equipment and assets is easier. So capital investment is always easier to make a business case and fund it. Okay, keep that in mind, right? And when it goes to a cloud, okay, so all of this capex is becoming opex. So one of the problem that I have seen in larger enterprise that was very capital oriented and like capital better than opex, right? They want things on the balance sheet, but not on the income statements. They're having really hard time at the leadership level, right? From all the way from CFOs and on top, is that making that shift in their head. Okay, they will say, okay, if it's a capital, take it. If it's an opex, no, you got to cut it. But cloud is all opex.
OpEx, yeah.
Okay. So that's one problem that organization trying to solve. The second is kind of related to that, is that we talked about speed to market, how fast you can move. Look, you talked about shortening the analytic cycle. The whole idea was that you create this hub and spoke model. You have a platform team with some real expertise of data where I operate in, and you have analytics team that do the last mile, right, and build those consumer facing assets, right, be it the mart or be it the dashboard and etc. And more larger organizations have moved towards that hub and spoke model. Now, why am I bringing that up in economics, right? Because remember, we talked about skill sets matter.
Yeah.
And skill sets are evolving, be it a Databricks or be it Snowflake or be it Azure. Skill sets still evolving, right? And more of these requires pretty deep full stack skill sets to do it.
Yes.
So what's happening is centralized team was the first one to start, evolve better, have equipped them, mature better in those skill set, writing a better code or better
Yeah.
components to efficiently use the infrastructure. But in their hub and spoke model, those spoke organizations are not mature. The teams are
Right.
not mature. So they're writing inefficient kind of really code. So that's pushing the cost very high. So
Yeah.
one is that the shift is problem. Other is that immature, the operating model is there, but immaturity in the spokes are actually pushing the cost high. That's another problem to solve, right? The third now we come in and this in an AI and a generative AI. That's also OpEx, right? It's an
Yeah.
OpEx. So I think that would further intensify that
Because
discussion and that
there are
problems.
far more number of coders now, technically, like developers in the business now,
Yes.
and they
Yeah.
care even less about kind of. I mean, okay, yeah. So that's basically what you're trying to get to. Yeah.
Yeah. Now the framework wise, what I it's a similar embrace that what at least I have tried to do in our organization, that uh, the unit of economics is almost impossible to really define. And what I mean by unit of economics is that I should be very clearly able to define a business KPI and attribute the cost of cloud infrastructure, the services I use. So then I can attribute the cost and I could charge you if you are the
Correct.
business person taking they have the value from it or deriving the value from it. That's almost impossible. The way the data supply chain is and the way the data pipeline works. So what I'm seeing that the framework is that there is a shared cost, and there is not shared or attributable cost that's the chargeback, right? That was the case in the data platform case, right? In of those three platforms we've been talking about. And I think that that's where at least organization thinking about even the generative AI are creating a conversational AI, or be it the workflows or APIs, that you got to have some centralized cost of it, and then the some part of it, the capability or use of it, will be a consumer attributed and they will pay for it.
So basically,
It's yet to what it look like, right? Yeah,
so
go
what
ahead.
you're saying is there is a, just so that I could kind of to read back to you. So there is a fixed cost of platform, which is
Yeah,
very hard to attribute it to a use case or to a business unit, and you're basically going to peanut butter spread through a finance process, right, across
that's
everyone. And then
or
there is a variable piece of it which you can which is much more easier to attribute it to usage or some form of it, like how many LLMs tokens are you using, whatever kind of that is there, and that you are kind of going to attribute it right into the different hub and spokes, the different spokes, depending on how much they are using. So that's kind of, you're breaking into two parts.
that's exactly that is you centralize the cost part of it, the common cost. I think it's
Okay.
we're in a much better shape to at least define what the common is. I would say better, not the best, but better shape in the data management world and the data warehouse analyst world. In the generative AI world, I don't think, at least I don't have a clarity what the centralize, but we got to say, okay, if the cost is this, we're going to centralize this much, maybe come out of a centralized purchasing, just like we used to buy the on-premise data center.
Yeah.
And then what is the last use case specific cost we can attribute to that, right? So that's but it's going to evolve over time. Maybe we'll get to the unit of economics, and we might be attribute all the cost that provide the value. But right now, I think that's the framework for perspective. Is there's a centralized aspect of it, and there is an attributable cost, be it the analytics or be it in AI world.
Yeah. And Mazhar, the pricing model of these tools, and it's just not one tool. When you start thinking about that, I mean, that also the kind of creatively changes at times, right? So like how do you decide which one is kind of the fixed and what is variable in your example? Like what will be an example of a fixed versus variable?
Yeah, like I said, most of my background and experience come from data platforms. So I'm going to use that examples. You can tell me more about an AI world right now. I'm just learning the large language models and how the economics is. I think for enterprise domains, right, the acquisition, ingestion, curating, enrichments of those, and even harmonization, though these are binding with any defined common schemas, that's all common, right? And I will call it share. So all the cost, processing cost and the compute cost that are associated with it, that could be centralized. Now, when you are building a purpose-built mart and all the data processing for that, or running a queries from be it Power BI or be it in analytics or be it a data science workbench and that, those are attributable cost and you can do that. So that's in the data analytics world, right?
The employee data coming in, cleaning, organizing, that's probably a common kind of, it's part of the common thing. But if I'm creating an HR, like a churn predictive model, that's the variable cost that potentially hits because it uses that data. Is that a fair example?
That's a great example. That's a great example. Same thing in an ERP system, right? So it's in the financial data, bringing financial data, standardizing data, that's a common. And if you're building a different views of it, be it for CFOs or CEOs or sales organization, that's more attributable. Right?
I see. So basically all the data consumption very quickly kind of goes into a, because it's easy to kind of track it to individuals who use it, who build it.
Now what I've been studying and thinking is that how would it play out in the world of this generative AIs, and especially a conversational AI might be okay to say, okay, we're gonna do this fixed cost, and we have a $40 or $50 subscription to every users who dial into my version of GPT, right? Or chat GPT. But I'm just curious that as we go into this solving the problem of, remember, we're going back to the data architecture problem.
Yes.
And we're trying to solve the data architecture problems, keep it where things are. If you already built the warehouse in Snowflake, keep it there, the structured data. If you are building your conversational or document AI in an Azure, let's keep it there. But build this agent, multi-agent architecture and use the orchestration layer to do that. How the cost would play in that? That's what I
have one other question, which I'm always curious about, and I ask most of the folks who kind of know the space well, which is unstructured data, right? I mean, if you think about it, and generative AI and enterprise unstructured data is kind of like number one use cases, but by and large, on like all the documents, contracts, all the unstructured data is kind of all over the place. I mean, do you see a lot of the unstructured data now will get centralized and get put into some version of a Snowflake cloud data platforms and everything? Because right now they are by and large in different SaaS or different application platforms, and no one has kind of brought them together because there was no tools to really do something in an automated way by and large at scale. Now that is there, do you really see the data like the central data teams and data platform teams centralizing unstructured data as a agenda?
Amaresh, another great questions. I really don't have an answer for that, but I can tell you what I'm seeing happening, right?
Yeah.
I see, I don't know Microsoft's graph, all right? So that's that kind of, I'm forgetting the specific name for it. It kind of work across the whole Office 365, right? And that idea is that any document, an email, or any contents, the unstructured content you're talking about within Office 365, any of those applications, you can literally actually scan that and we'll be able to synthesize and answer those questions, right? So that's if it is within the Office or Microsoft 365. But I think your question is that let's look at an example of Medtronic, right? There is a clinical data sets, right? The clinical documentation, right? The trials documentation, and they are not they're somewhere in the clinical platform.
Their own application. They are like buried in their own application. Yeah.
Or manufacturing. There are maybe some drawings and all this kind of design. They're sitting there. So do I see that getting centralized? I think that's where I'm still kind of scratching my head. I'm thinking that if we are talking about creating this multi-agent architecture where agent has specified role, can use the different tools and skill set to do that, maybe there is an agent running out on all these repositories, right? And will do complete their task and give the output back, and that can be consolidated for the final output. Again, we're really talking about something that's I have not seen it implemented, but that's still evolving, right? I think that it might go back to between a hybrid of what the Hadoop promise was, and what the traditional data. Okay, bring data to the compute, and Hadoop said no, bring compute to the data. It might be a hybrid of that. Right?
No, because I mean it's been years and years, and like that is like decades that has taken to like consolidate, kind of create these data lakes in some ways, and now we have and that structured data is probably a fraction of the unstructured data that is sitting out there, right? I mean, if you start moving all of that inside, anyway. So I know it's a fascinating question, but it'll evolve. But Mazhar, you're always very kind and very thoughtful. It's so much fun to kind of have the conversation and really understand what's going on, what's real versus what are the challenges. I love the discussion on economics, on kind of how you think about it and some of the challenges around it. But thank you so much for coming and sharing and driving the insights, and we'll chat more soon.
Well, Amaresh, thank you. I really appreciate all the thought leadership coming from OXO, and thanks for continuing to share. I read your every article you publish, and I'm always learning and evolving. So thank you very much.
Thank you.
OXO AI. What if? What's next?